Hello. Generally speaking, I do not deal with monitoring and logging as such. Generally speaking, I have plunged into this problem once from scratch, simply because I needed to. But generally speaking, I deal with something that you can call data science, and some applications which data science sometimes they get into production and you need to monitor them somehow. The monitoring is in the hands of DevOps, usually, and it's their problem. But it's not that simple, it's not that easy. I will be talking about that, and I will start with logging, generally speaking, how it works. We have already heard one talk devoted to logging, but I would like once again to add my penny worth. So, why do we need to log anything at all? First of all, I have developed some chunk of a program, and I started. It works. It has been smoothened for years, and it's all cool and smoothly running. It does everything it needs to do, but what exactly is it that it does? Why the message received, why it passed successfully. But we need to know. We do need to know. We are programmers, we are developers, and we want to understand what happens. What happens with logging, with monitoring. We actually, in certain cases, we just need to know what happened. The same. In principle, adding some code, adding a couple of prints, we start to understand what exactly is happening, what exactly is going on, and in what order. As a matter of fact, maybe it worked for quite long, and it worked slowly, and we actually can see it and can understand it, and if we start it once again, then probably it will happen in a different order, or there will be different order or events or different speed. We don't actually know why it was happening like this. It's completely obscure to us. Okay, let's add time parameter to our prints. That is the most evident thing to do. And subsequently, we have popping up 2 or even 3 completely useless lines. And generally speaking, it's much better to do it not via prints, but logging. Logging is not liked generally. It's not very popular. Those people who do with machine learning and who sit in repository and you can actually read something in blogs, like I replaced prints for loggings, and for 30 minutes I couldn't actually do anything at all. Everything disappeared. Well, it's understandable. Indeed, the call for logging configuration, even the simplest one, not speaking about complicating settings, even the simplest one, actually, for the logging to work as a print, it looks as a magic spell, which nobody can remember and everybody copies that, or they take it simply from some framework which is pre-prepared for them. But if we speak about the developing of their own program, then without frameworks, then it's Stack Overflow is something to help us. The logging has a very important advantage if compared to prints. There are handlers, for example, and he is capable of doing different things. Like I would like to ask him to show the current exception or a set of exceptions like entry. It will be switched via logging, and generally speaking, everything will be cool. It's all very well. Let's continue. What else can be done? As a matter of fact, it seemed to be all right, but I do think that the logging can be mixed with monitoring or mashed with monitoring. You can monitor and do and monitor the logs as well. And you can simplify it. At the moment, you can see the time. how long it was between certain events. For us to understand better, we need to parse the loggings, or we need to calculate one timestampers to the other, or the logs should be passed to the machine readable type and then calculate something. It's not very good and very comfortable. Let's consider a little bit more complicated example. It's going to be a bit closer to reality. There is a server, and we need to read a client which will be readable. So here you can see it's pretty much the same. There are two functions similar to the ones that we talked previously, receive and heavy parse. So we just save the file, and I'm not going to show the code of this server. It's all very well. Now I'm starting the server. I was lazy and I didn't want to make a separate image, and the internet is not very fast here.
Можешь на провод, кстати, пересесть? О, а мне, блин, образцовки было, что будем сидеть на проводах. Ну окей. Не смогло. Так, а интересно, не смогло совсем или не смогло чуть-чуть? Не смогло?
Okay. Error response from daemon.
Ускорите интернет, пожалуйста.
So, can we speed up the internet?
Ну, на самом деле у меня есть запасной вариант.
I have a backup.
Есть образ, который написан.
I have an image that was developed for the client, and actually I suppose that it will be good enough for us as well. If we won't start it there, we shall go to the client. So, now I suppose we can bet for 1 to 3. 50-50. Well, I suppose it will work like this. But there is a conflict simply because the name is already occupied. So most probably it has already started. We can suppose it is like this.
Очень нужен. Но я к Wi-Fi подключен. Так, ну, он говорит, что его нет. Значит,
it is not here.
Да. Ура!
Hooray!
Хорошо. Сервер запустили.
That's good. So we have started the server, and the client will need to do pretty much the same. Okay, it's a spoiler. So what does this particular asterisk mean? That it works? The follow means that we follow the logs, and the figure in brackets, that means that we finished monitoring the logs. Why? Because I spoiled it. So why client will crash? I don't know whether you were monitoring the code or not, but we probably have noticed that we used the memory view. When we use it, we need to let it go. We either use it alongside with the context managers, or we do it manually, but very cautiously. Okay. Let's just restart it and see what can be done about it. So you have restarted, so there is memory flow. And in half a year it will crash, so we shall restart it again. No problem, it seems. As a matter of fact, people will find us. We can't get away with this, simply because our program doesn't work. Maybe it will start and then crash, and the Docker awakes, and maybe it was a system D or supervisor D, whatnot. So, it's more or less clear, but how do things right? So probably crash reports, I'm not okay. Within this program, it's quite difficult to do. For instance, there are no chances for it, and but generally speaking, in restart we can do some script that will send a report, but that's not enough, that's not sufficient. And we can actually send some notification that we do work, that we continue working. It's either some distributed parameter, and as soon as we stop notifying that I'm okay, we will probably start being alarmed, but it doesn't rule out the previous position. So apart from goodness, we can also, or fitness periodic reports, we can also send something like I'm fine. There can be business logics that is processed, but the memory is 99.8%, and it seems to be okay, and the flow grows and so on, but there will be just if there is an overflow, then there will be a downtime of 40 minutes. It can be push and pull system, and there is a pull status, are you okay? But it doesn't rule out the previous ones. So, for instance, when we ask from the external server, like, are you okay? What about the liveness? But it doesn't rule out the previous again. Why not? Because the network engineers or just the system administrators, they will, if you see the internet, it doesn't automatically mean that the internet sees you. So also it's quite possible that if you pin somebody, if the server, for example, that checks your life, if it verifies that you cannot continue living, then you have probably lost all the metrics that you could have collected within the remaining lifetime of your program. So the metrics actually can continue being collected. This is a very good material, in fact, to investigate what actually happened. But if there is a pool several times per minute, then within this intermediate interval you can lose this data simply because the connectivity was not there for unknown reason. So why do we do the monitoring? I hope that I have explained it somehow. Sometimes it does happen so that you need to deal with something that actually crashed, even if it happens at production. It's dead, Jim, so things happen. And it's not only for this. Sometimes you need to monitor how the metrics are interrelated, so you have to track correlations. Sometimes you have to consider the general overview of your application behavior. If you look at logs only, you will see just one log, and pre-business logics. It's exactly like the site will be growing, the flow will be growing, but you should forecast this, you know, the situation with crashes, and post-mortem analysis is something that we need to do sometimes. So, as I see it at the moment, this is how the monitoring process is how it is structured, and this is the composition of it. I will cover it separately. So some of the solutions are prepared for us, others need to be somehow adjusted, and some of them require our minimal participation. So I'm going to start some containers with these blocks. As they are starting, we can consider the some of the bricks. This is the way our users interact. So on the dashboard, you will see the metrics, you will see some beautiful graphs and so on. To your email, you will have notification about something, some problems that occurred. Then chatbots, that means that it's not only notification, but also actually you can communicate, like changing the threshold and so on and so forth. So this is what the users interact with. And here, as a matter of fact, you don't need to do much. It's either on the second level. You don't need to invest much of an effort here. There are other levels. This is stream processors and also the EventDB. EventDB, roughly speaking, is a database which stores all your logs. It's not just metrics, just values, but all the changes and updates to them. So you can get the figures from them, as a matter of fact. And some would think that it's quite an expensive thing, and depending on whether you need pre-processing or not. If you have HTTP server and there are 3 inquiries, then you will have 300 notifications here, and then in TSDB there will be 1. Subsequently, these metrics, they can be collected from different places. They need to be combined somehow, and this is exactly what the stream processor deals with. Some additional metrics can be calculated, and the metrics can be as calculators, for example, and they go up, and you need to monitor the fluctuation, how much more it grew, and comparing to a minute ago, for instance. All these things are already there in the market. As the EventDB, I'm not going to show you anything, but as TSDB, I will show you influx and Prometheus. As a stream process, I'm not going to show anything, simply because it's quite difficult to give you an example, like it can be capacitor from the TIC framework, from the InfluxDB authors. And also there are certain places where you need to do something, like an aggregator comes from 1G. This is sources, events, and alert aggregator. This is exactly that sorts out the events. Like there is an event and we ask from the server. And also, for instance, there is an object that you failed to create and develop, and the sources, this is something, that means sources of metrics, of values. You write once in 30 seconds, for example, some report about amount of bytes, the order, and so on and so forth. It's something that should be implemented. You never get it from the air. And as of today, at the moment, you have to work with aggregators of messages. For example, you need to work with the bots. And at the moment, I'm not aware of any particular instrument that you can borrow from the toolbox. I hope that it will be changed in the nearest future. As of today, right now, You cannot just take something that is already prepared. The Telegram can block them, or vice versa, it is not sufficient, it's not enough, and well, I suppose that we should have already started by now, and we can start collecting metrics for our app. What is what here? There are several types of metrics, and the main out of them are the calculators, the counters, the summary, and the gauge. This gauge is, they can go up and down, and the counter can go up only, and the summary, they can come in two types, in several types. They combine several types in one, as a matter of fact. Here we're going to use the counter for a number of events. We're going to use almost the counter for the number of bytes, and also we're going to use metrics for measuring time, how much we needed actually to receive an event and also to process it. I'm going to add the metrics of how much our current application, how much of the memory, of the operative memory, our app occupied in Prometheus client in the library that I use here needs all the necessary tools, and here I actually did it just to show you, just to demonstrate, for a matter of demonstration. These lines are not of interest to us at the moment. We shall need them slightly later for me to export the data much easier to other sources apart from Prometheus. I will show you later why. It's quite cool. Now, I suppose we can do some start. So we shall actually send several messages to Prometheus that is already started somewhere in the Docker, and we shall see what it is going to do. So first of all, we are going to create an HTTP server, even if the application does not envisage that. These are instruments. So we have come from the instruments like, adding a print to understand what is happening to the instrument of incorporating HTTP server. And that's okay, that's normal. Apart from that, we're going to start some other flows that will export this matrix, and it's also okay. If we are limited and restricted in our resources, if we need to work in the incorporated inbuilt system, then probably we will not be capable of starting an HTTP server, but the threat of UDP packages, I suppose we are capable of doing that, and that's exactly what we are going to do. Probably not today, but if we start working in the controller. So we actually are going to start this heavy parse operation, and we are going to wrap them, which is done by the decorator. We do the wrapping, and which will measure each of these functions and how much of memory they needed, and what kind of metrics should be enlarged. After which we start our message, start our and enlarge our counter, the number of bytes, only if we received it, and if there is no timeout and the message is not empty, then we parse it, and we have the result. So we finished it. Now let's look at the format. What actually does it send us? As a matter of fact, in Prometheus, they sent. Oh, they actually asks for this data. This is text format data, and sometimes it's even simpler than that. This is just...
Я не знаю, имеет ли смысл выбирать. Давайте поговорим. Здесь мы определяли, когда написали, что такое за метрика, мы написали ее короткое название и
I have stated this matrix description. So it will come here, help, and further on. Type is one of the types of Prometheus, what they call counter, summary, and gauge, or num, or whatever it has. Then there are metrics like labels. Labels I'm not going to discuss, and also the values. And all these are accompanied with the time from the very beginning, and there are also metrics which will tell us about when and how. This is quite a simple format. The Prometheus client library contains the parsers even of this format, and more to that, I would like to say that there will be even simpler. And we shall be discussing simpler versions. Now let's look at what is happening in Prometheus at the moment. This is, we have opened the Prometheus, and one of the metrics, you can see that it exports and imports metrics, and by default it is not very different, although most probably you don't need it that much, but in the Python client repository in Prometheus, there is an issue and other tools that allow us to exclude, to just rule them out. This is the messages, and we're going to find them now. This is counter total, and
график с этим. Ну давайте байты попробуем, я не знаю. О, хорошо, байты получились.
Okay, these are bytes.
Ну, то есть вот приходят какие-то сообщения, да?
There are some messages, incoming messages. We did something to them. In this particular interface, if we add more graphs here, then it's quite difficult actually to understand what is happening here. And there are more interesting tools and instruments to do this. I would like to show where and how these graphs are derived. Our metrics, they most probably live in this client. So we have done this HTTP call or inquiry as a typical inquiry from Prometheus. So this is pretty much the same as you can get from Prometheus, but in a tricky way. I prefer to export metrics to influx XDB. Why? Because in graphite, later on, I can group them in a much more interesting way, and that would simplify my dashboard development. So the easiest one is to use the graphite protocol. Graphite protocol is quite simplistic. It is pretty much the same. The client that we started, I modified it somehow, and it exports certain metrics. This is graphite protocol. It has first name of metrics, then values, then timestamp. And that's it. This is more than enough to exercise monitoring. This protocol is much easier than the one in Prometheus, and it's a little bit more complicated in terms of the influx format, but it's much more flexible, and it's neither more complicated than graphite. Now let's look at what we can do with it. So first of all, we need to start exporting the metrics from Prometheus. And Prometheus, the client rather, has an expert data which will create a flow which will send this matrix in the format that we will need to, we will have a chance to parse in influx. I will look at the influx API address. This HTTP address doesn't tell us much because these previously these were cool things, but at the moment these are API only, and you need additional applications, and but we have Grafana, which allows us actually to look at pretty much the same. This is a freshly started Grafana. That's this will be our password, and we shall leave it open because it is inside the container, which is safe from the rest of the world. And so now we need to match our Grafana with Prometheus and influx. When I started Prometheus, I stated IP Prometheus address. So it must be very simple. Looks good, and we can actually look through some pictures to see some graphs to see what Grafana is capable of. This is a default dashboard for Prometheus. And this is the approximate value of what the Grafana gives us. All the metrics are shown in one screen in great numbers and amounts, and especially if you understand why you need them. That if you don't understand why you need this or that metric or value or figure, then there will be hyperlinks from Grafana and from Prometheus. This is a good dashboard. Now we are going to create a couple of poor ones. We are going to also start the influx. Again, Grafana understands everything about influx, and they're meshed very well. So also for the Docker to know about influx, I stated here in the address. And also here we need to state Grafana as we are. As we're sending it via graphite protocol, there is a separate database designated for it, and that's exactly where we shall be deriving our graphs. Everything being well, we will have an opportunity to understand what was wrong with our application, why it continues resetting and restarting all the time. Grafana, if we cooperate with influx, allows us to do it in an elegant manner, but Prometheus doesn't. Let me first of all demonstrate non-elegant method to you. So we did not start for 6 hours, and we have some 15 minutes in stock. We can select one of the metrics that we have been operating with. For instance, bytes total can be seen once again. You can see here this saw-like graph, and you can guess actually what went wrong there. As a matter of fact, yes. Look at the influx now. What I like about influx is that the Grafana can actually load the tags, and subsequently we can teach people to do the calls without influx language, without knowing influx language, because we need to work with this language otherwise. If all the settings are all right, we can state the bytes here. Here you can state we can use the list here, and we can select everything that is relevant to mem and bytes. We group it by hosts, and even the host In the current notebook, it's not relevant. We shall start working with the container, and that's actually what we don't need as well. Now, you can see what is happening. You can even zoom it, but we shall add some pixels, because otherwise the resolution will be not enough. So you can see that the volume was growing in a linear manner alongside with the number of bytes, and it continues to up to a certain moment, after which there is an overcommit, and the swap is not switched on, as you have probably guessed, and this is the end of the story. But not actually the end of it. I don't like the non-elegant method that the programmer needs to resort to somehow fast create a system and continue working with it. How does this work look like now? The matrix that we created, you can see the decorator here, the function that we called, also another decorator for the same function, and there are the so-called irrelevant additions to the code, which are instrumentation, like which exactly we created here. So we have developed and added them. Great number of calls, but what we need to draw attention to, that all of them go hand in hand with the places where logging can be used. We can actually change the state of our application. This is type of metrics. We can actually add the counter and the counter messages, and we shall nonetheless add it to the log. This is what we have currently. I would like it to see it in a following way, without spare of the following problems. First of all, by measuring this time of functions, we do not understand how much of that was spent in vain. Even if the function ended up in 4 hours and we needed to restart it or ask for another call from a server, we didn't get information about how much of this time, in percentage, for example, it worked successfully. We need more modules, time it or something like that, which is not very elegant. So by default, in both Prometheus and Graphite protocol, there is float 64 for matrix, and these are not always the best thing to do. In influx format, you can avoid it somehow, but it's not that easy to actually connect it to your program, to your library. You need to devise something and do something very laborious, or use this float 64, which not everyone is happy about. Especially if you are happy with your matrix and all of a sudden you get very high values and you need to round them up. But on the other hand, I wouldn't like to develop for each matrix a description, because I already have it either somewhere in the code or in a log line or in a docstring function for which I create a timing. I do have already the info. Why not use it? I also dislike the fact that in the descriptions, by default, there is no data type. Float 64 can be different. These can be bytes, these can be packages or packages per second, a number of people passing through the door, whatnot. The question that is of interest to me is what kind of matrix should come within one graph, within one scale. Having such opportunity, I can create a dashboard much faster. I don't even have to create a dashboard. I can just consult the graph. which will not be needed by anybody else. When I'm pretty sure of my metrics, I will send it to other people, and people will be constructing dashboards for me. And last but not least, registries, which for a long time was behind the scene. This is the object which in Prometheus stores all the metrics, and it's not linked with current module. It adds additional code lines, which I don't actually want to add because I already have HTTP server in my head. What else can be done? You can somehow do it somewhat differently. Let's imagine there will be a library and logmon, which will behave very similar to logging. There will be a registry for our metrics. It will be hierarchical. There will be different modules with different sub-registers, which we can use in dashboard creation and with full understanding of where the metrics are derived from, with additional information on what they mean. Sometimes we need to import timeit. If you need to calculate time between two events in the program and they cannot be united within a block with context manager or within one function, then you will need to use the timeit and somehow calculate them later. So sometimes I have seen the codes which actually utilize this timeit, and later on they create something like logging, debug, and the function actually like T1 minus T2 time. Very convenient, very convenient. I'm not the only one who saw that. I see. And instead of that, maybe it's reasonable to have the following lines. If you need to operate with such timer, maybe it's reasonable to do just one, give it different names, and it will be registering the time between all the previous events that he needed, that he had to collide with, and he will be logging them as well if we ask them to do so. But that's not the only option. As a matter of fact, we can do it differently. But first of all, let's come to think what can be done right now without actually much ado about the additional library. First of all, we can create a bulk of data for all the current metrics, hierarchical or non-hierarchical, and this is a whole bulk or mass of data. It can be introduced to a log or to graphite, or we can create something ourselves. You can see how simple the protocol is. This is the protocol that can be implemented by a netcard. You just send it to the server that listens to it. You don't even need an additional library. And in many cases, when you need to create a small application and to have a monitoring system, you can add the Prometheus client overkill by EDP or ATCP. It's not something good. There is another option which will appear sooner or later, I suppose. And unlike the other slides, it's a working code. For the current moment, it's not dealing with the monitoring, but you can add a handler which passes some types of lines, or you can send certain objects to the log, which will make the objects look like lines if you need lines to be seen. And further on, You can do pretty much the same as the previous example, but at the same time, you will see much more customary logics. There are certain disadvantages because it envisages quite a strange format of the logs, and take into account how much Python standardizes the logs. They must also come in a standard mode. Maybe somebody will find it too much boring and dull. But if something appears in logging module, then I suppose at a minimum this addition will not expand the logging module that much. It will be just a handler that is capable of doing a couple of things, and its setting will not occupy much of the code. But logging at the moment is so extended, and most probably it will give us an opportunity to ground everything. So I would like to finish all that, again coming back to the ground. What can be done now? When you develop a program, you will be using some logging. We should not be using prints. That's so much for them. That's enough. Try to think about the metrics that you can collect here. Even if at the moment you don't incorporate the monitoring because it's so complicated, you can add some calls, some metrics, some figures to this log. Maybe it will be very useful. On the other hand, if you come to do so, maybe there will be a handler that will do the monitoring instead of you. You can create a big object, one, and in this particular object you will store all the necessary items. You can log it every single time, or just analyze certain lines from the log. From the logging module, you can actually do logging, info, and not just /s, but apart from that, you can ask for some object inside the dict, like this, for example. The idea is pretty much the same. If dict of an object, for example, if you have big state here, then you don't need to call for everything, but the logging already will receive the object, and some handler will have an opportunity to deal with it. And as a matter of fact, we already have such object as globals, but I do not recommend globals here. That's the end of my talk. Thank you. I don't think that you have questions, or do you? Thank you for the talk. In the beginning, you said about machine learning. Do you use it in the machine learning? Yes. When you at the stage of production, you have machine learning as already forecasting. As you use the model which is quite complicated, for instance, neighbors, network, then you will need to think about how long the forecasting takes. In some models, the forecasting can be too sluggish, or the forecasting results will be of low probability, low value, low rate or scale. Not scale, but okay, you understand. So in machine learning, the metrics that you trace are great number at the stage of forecasting and learning, both. Any more questions? Have you ever come across problems of database consistency of Prometheus or influx? So, both Prometheus and influx, these are DB for metrics. These are DBs that store your system. The business logics must not be there. If you want to store there something and build the clients, okay, try to do it. Well, I twice came across the situation with Prometheus, part of the metrics. It didn't aggregate them, although they were there, and we could see them inside the Prometheus, but it didn't aggregate them, and nothing changed. And second time, all the aggregations were just broken down with Prometheus 2. Maybe that's why I use influx more. But we haven't come across that, no. With Prometheus, no, I don't work with it so much. I actually need to derive the metrics. It's a backup.
Спасибо за доклад.
Thank you for the
Если я
talk.
правильно понял,
If I understand it right,
у вас логинг это как
the
бы
logging is
wrаппер для отправки этих
wrapper
данных в мониторинг.
for sending
То
data
есть
to
у вас есть
monitoring.
какой-то хендлер, который
So you have a
парсит вот
handler
этот
that
логинг,
parses this
ну,
logging
передаваемые ему сообщения и, соответственно,
to
отправляет.
the
Или это не так?
messages, and well, I suppose that you can do something the like. But at the moment, I cannot, I don't have a universal mechanism with a separate module. But this is exactly what I do. That's something that I showed you at the last slide. As a matter of fact, this is some sort of thing that has storing the objects and showing it to the stream function and sends them to by TCP or to HTTP to influx.
Это логично, но
That's logical,
с точки зрения вот,
from the viewpoint of
того, что человек, который не знаком с этим кодом, бы
if the
смог
person is
разобраться,
not
мне
aware of
кажется,
the
было бы,
code,
наверное, интуитивнее
I
все-таки
suppose it
мониторинг
will
делать
be
как
much
бы
more
отдельно и
intuitive
явно,
to
а
do
логинг отдельно,
separate
потому что всё-таки
monitoring and
немного
logging
разные
separate,
вещи,
because these are
как мне
different
кажется. Ну,
things,
в принципе, да,
as far as
это
I
два,
think.
наверное,
But these
подхода,
are
которые один другой не
most probably
исключают.
two codes. Well, in the majority of places where you do logging,
Да, но можно просто для
it's
этого
a good
сделать
idea
как бы
to send data for
явный-
monitoring.
Нет,
Well,
явный вызов
do you
того,
need
что это
macrosses?
идет и логинг, и
No, it's a
мониторинг. То есть
logging and
не
monitoring at the
используя
same
как
time,
бы
without the
подкапотный
use of
класс хендлера
underboot
логинга, который где-то там будет
handler logging
определен, и где-то
class,
через конфиг он, соответственно, будет
which will
задаваться.
be
А просто
done by
сделать явно,
config.
чтобы было видно, что этот код будет всегда данное
just
место
to see
будет
that this
всегда
code
логировать
will
и
also be
мониторить,
logged and
чем
monitored
отложить это на стадию
without
конфигурации,
actually
потому что придет
postponing it to the
конфигуратор, там,
config stage,
законфигурирует и все
because there will be.
Я согласен. С другой стороны,
I agree on the one hand.
показывал эти примеры в
On the other hand, I have showed you these logging examples, and here we have certain characteristical data. Those who work with this code, they most probably understand that it should be configured like this and not anyhow differently. Even if it is not configured the way you want, it will work nonetheless. And also there can be some object that can lead to a line. If there is a handler, then this object will be taken and everything will be all right, but if there is correct handler that will send and aggregate the metrics, it will do everything well. And this object will be, you will have to operate with it, and for example, you can introduce an alarm there. I would like to add, I would like to say that approach with a smart handler. There are two problems. First is productivity, because it's overhead, it's parsing and then sending. I have a SyncQ application, and the logging module cannot do anything synchronous, in a simultaneous manner. So the loop actually stops, comes to a halt. Most probably it's not applicable for such things, and you should remember about that. Most probably there is a more universal solution. I don't actually think that it should be that. I know a person who parses the IST tree, and he receives 10% of productivity. Anton Patrushev, okay. I understand. So most probably this doesn't add productivity. You don't lose productivity if compared to regular logging. If there is some parsing that happens, nothing actually. There are separate options, and most probably it happens with the multiple flows, and I don't think that ISync.IU should be done. I suppose that such things should be done in a different application. This is raw data, and we pass them in a different place. I suppose it's more correct way. I think, what does it mean to parse? You can parse a huge procedure, or you can do something which is RAE2 or hyperscan that will crack it much faster than you will even recognize the problem. There are options, and at the moment we do not have any standard implementation. And at the moment, in fact, there is some of the sites that will probably start off sooner or later, or maybe in the nearest future even. Any more questions?
Здравствуйте. Я хотела бы знать, используете ли вы какую-нибудь систему алертов для быстрого реагирования на мониторинг, либо ограничиваетесь просто
monitoring changes, or you just send messages to Telegram or to email? It's hard. It's a good but hard to answer question. Kind of painful. Yes, we do use. But in many cases it is for a very specific application or app group, something specifically made for that purpose. When I showed the slide where you need to work, we add sources or aggregators. Yes, we have some time. For instance, sometimes if something happens in several locations simultaneously, it is the same event. It is better to send just one message that this event happened in these places. It is better to send one message that it happened in those locations rather than 30 messages. Nothing good. There is no good solution without any, so to say, negative features. I hope it soon will appear, and that something will appear that we will work with, that will be easy to set up, but it's not yet at the moment. We have to use sometimes some scripts. Maybe I haven't listened to you from the very beginning, so maybe you will repeat some stuff. But I would like to ask you: have you tried the Python code and Python applications to do logging and to do all the monitoring and notification to be done by some to use for them some specific monitoring solutions whereas monitoring speed and optimization to be, so to say, applied. Well, actually, it comes from this idea, from that thought. So the one of the first idea, how to implement logging in the application, how to implement a monitoring application which is do not do logging. The idea is, first of all, to pass it through the shell script with piping, which will add up a timestamp at the beginning of every line, and then pass it through the piping, through some log collector will transform it into some special instruments like statsd or ndb, and this topic of log monitoring is quite a large topic. There are lots of options in open source about log monitoring, but the problem is log monitoring is just additional step, and it means, moreover, that in a text form, each time you have to print lots of data in this string. I show you that's what by default Prometheus prints by request of your application, and except for some trivial Python versions, all the data should be provided. And just think about your log. If you go into print out everything, and if any of your requests will have 10,000 metrics, and you have a million of users, just imagine it. Yes, it tends to be quite sad issue. The idea is that the application writes log, but log then is processed quite separately or handled some separately. Yes, it's a good idea, but how? Yes, because then you have to write down log, which will produce several gigs in several seconds. That's real. That's real. Yes. Well, sorry, I can't hear your question. Not into the mic. Sorry, not into the mic. No, it's not a module. It's just hypothetical stuff. Sorry, we're out of time. We're out of time, but you can. Yes, you're gonna have lunch soon. Then you can continue the discussion in the discussion area, and we need to give an award for the best question. Well, I think it's about the question about the Async.io.